Yes. So on today's session, so we are going to see about two titles. So they are, the first one is Straingauge sensor or Straingauge, and the second one is LVDT. So LVDT means linear variable differential transformer. So this we are going to see it in detail. So first one is strain gauge. So before getting into strain gauge, I'll show you another existing mechanical system. So then we will understand why strain gauge is required. So this load cell you would have seen. So the load cell is used to measure the stress or the pressure or the force being applied. So this is a pneumatic load cell. So the pressure or the force is applied here. So that will change the air pressure. So accordingly, the meter is going to measure it. Even our hydraulic system is going to be the same way, right? When a lorry or some truck goes in, so it will affect the hydraulic system. So this load cell. So this will eventually disturb the the oil inside if it is hydraulic system. So accordingly it is being measured, right? So basically load cell is so this is the same pneumatic mechatronics. So this is basically a strain gauge. A strain gauge basically has a metallic foil. Foil means something like a spring arrangement. You can see the picture here. So it is a metallic foil being arranged in this way. It is something like a spring kind of arrangement. So when you place something, when the pressure or the stress is being applied, the distance between or the tension of this foil is going to change, increase or decrease. Tension and the distance between this gap of one winding to the other is going to get disturbed. Either it is going to compress or it is going to expand. So accordingly, what happens is the resistance of the entire coil is, means the foil is going to change. So like previous one, angular movement was converted into a resistance variation. Here the stress being applied, or the strain which is exerted is going to convert into a corresponding analogous resistance value. Analogous means a same concept, a same thing seen in a different fashion. So that's analog mode. So all the signals that comes is analogous signals. Analogous analogy in subject when we teach, we used to mention, right? So that's what. So here the basic working principle is force or stress is being applied. You see, stress is something being applied. Then it goes to the strain gauge. So the strain gauge is the transducer here, right? So this, the construction we are going to see, adukku munnala we are seeing a one-line principle. This strain gauge is going to convert it into a corresponding resistance variation. So this is the bottom line principle of strain gauge. Force or strain or the pressure being applied is being converted into resistance variation, right? So now let's get into how it looks like. See, I told you that this is a metallic foil, right? So this looks like a diagram. So this is how in actual it looks like. See, so here there is only one strain gauge. So here there is an array of strain gauge. There are 1, 2, 3, 4. So these are kept in machines so that when something goes and hits, it could be something like constant hit or something like. So when you want to measure at what force or what pressure is trying to hit or what is the weight of something, so then we'll try to use the strain gauge. So it can be anywhere. So both are the real-time pick that is being fitted in a machine. So accordingly, according to the requirement, either we'll keep 1 or an array of strain gauge. So this is how it looks in practice, right? So how do strain gauge reads a value? So this is the question, because strain gauge bottom line principle, I told you, the force or strain or stress being pressure or being applied, and there is applied to the strain gauge, it converts into resistance variation. So what? How do we get the voltage variation? So this is how. So when we connect it to a circuit, inga vande we call it like a bridge circuit. There are four arms, the bridge is balanced. So according to the resistance value, the voltage drop across the resistance will vary. இங்க R1, R2, R3 are constant resistance. Their values are not going to change. Whereas in the fourth arm, the strain gauge or the potentiometer, whatever, in the resistance variation transducer, even if you connect it, according to the physical quantity, the resistance is going to vary. When the resistance varies, the voltage drop across this arm, you can see my pointer, is going to vary. So அப்படிதான் the voltage variation happens. Voltage vary ஆயிடுச்சுன்னா everything is over. So that can be read by using a voltmeter or whatever, right? So that's how we work. So the stress or strain or force or pressure applied is being read out in the meters in this way. Basically, it shows the difference in resistance variation. Other circuit la connect பண்ணும்போது it shows a voltage variation or a current variation, as simple as that. So hope I made it clear. So strain gauge simply changes the pressure or the force or the stress or strain applied into resistance variation. So as simple as that. So other circuit la connect பண்ணும்போது you get a voltage variation or a deflection in the meter, right? The second title of today is LVDT. You need to listen because I have asked a question. So abbreviation, linear variable differential transformer. So before going into it, there's a prerequisite, or I need to ensure whether you know transformer. So we'll see first what is a transformer, and then we'll go with the other titles. So this is a transformer. So you would have seen it on the street. So this is a real-time pic, and this is a transformer. In any audio video systems and televisions, you would have seen this small little tiny one. This is a big one, right? In our power transmission, இது யூஸ் பண்ணுவாங்க. இது எல்லா கேட்ஜெட்ஸ்குள்ளேயும் இந்த tiny transformers இருக்கும், right? So basically transfer அப்படிங்கிற வேர்டுல இருந்து this transformer came with, or transform அப்படிங்கிற வேர்டுல இருந்து transformer came. Transform means from one medium to another medium, from one shape to another shape. Converting is what you will call it as transforming. Converting is transforming. So since it converts, since it transforms a lower amplitude signal or low voltage signal into higher amplitude signal, high voltage signal, you call it as transformer. Transform பண்றனால we named it as transformer. And so as simple as that, whatever is the operation of it, the electronic guys used to place it, means name it as, that's the name for it. So transformer, working principle of transformer, you see there is no physical connection between two windings. There'll be two windings. One side you will give input. See, blue color is input and red color is secondary. You get an output, amplified output. There is no physical connection. Red and blue is not connected, but they are linked. See, they are not connected physically, but they are linked. So through a core, a magnet, means iron core. So there is the link exists in magnetic flux. Any current carrying conductor. இது வந்து physics. This concept is used in LVDT. So transformer concept is used in LVDT because LVDT is a kind of transformer. It's a linear variable differential transformer. ஏன் இந்த நாலு வார்த்தை வருதுன்னு I'll try to explain it to you. So linear variable differential transformer. So before getting into the title, I want to show you that this is how it looks like in practical. So this is a linear variable differential transformer. So from this sensor, the wire goes, so this will carry the electrical signal. See, this is the movable arm. So linear variable differential transformer, எதுக்கு use பண்றோம்னா, it is used to measure the displacement, movement. A linear displacement, angular displacement means potentiometer. A linear displacement means either horizontal or a vertical. So a linear displacement will try to use a LVDT. So ரெண்டு kindல இருக்கு. So left and right one. So you can screw it somewhere. So this is the movable arm. So what is movable arm? நம்ம பார்ப்போம். Linear variable differential transformer. So even in this, there is a primary, but there are two secondary windings. The two secondary windings are connected in opposite way. So and the end terminal is connected to the first. So in this way, it is connected in this fashion so that the output would be a difference between the two values. So there are two secondary windings, secondary winding 1, secondary winding 2. இதுக்கு across ஆக்குறது V1, இதுக்கு across ஆக்குறது V2. The total output will be V1 minus V2 or V2 minus V1, whatever it may be. So it is a difference, not exact minus. So it is a difference between two potentials. So that is why differential transformer, right? Linear variable differential transformer. So differential, why that word differential? Because the output voltage is a difference between the voltage of two secondaries. So adanal the differential transformer. Here the second point to note down is the core. Previous case, the core was an iron core, it was a fixed one. அதாவது இங்கே the core is a fixed one, iron core is fixed, the coil is winded. Whereas here the core is movable, it can move upwards or downwards. So I told you the core is the one which links the magnetic flux. So the core is movable here. So that is why the core moves in a linear fashion, not an angular fashion. So the linear movement results in linear variation அல்லது linear difference in the output. So that's why we call it as linear variable differential transformer. The movement is linear, that results in a linear variation in the output, and the output is a difference between two coils output. So that's why it is linear variable differential transformer. I think I made it clear. இந்த இது பாத்தீங்கன்னா உங்களுக்கு ஈஸியா புரியும். So this is an animated, not an animated one. See the core, the iron core is movable. So wherever next to or GIF animation, so that will tell you how it works. The core can be moved upwards or downwards according to the movable arm. So when the movable arm, see this is the primary. See my arrow marks, inga wind ஆகி இங்க போயிடுது. So this is primary. This is secondary 1. இதோட end secondary 2க்கு போகுது பாருங்க. So secondary 1க்கு 2க்கும் output voltage இருக்கு, right? So when this iron arm moves upwards, the voltage at these upwards secondary coil will be more, because in the iron core is going to link the magnetic flux. When it moves downwards, the voltage of this coil will be maximum. So the difference will be accordingly, V1 minus V2 or V2 minus V1. Wait, I'll show you an animated one. You can see it here. Core is at the center. Now core moves this side, upwards or left side. So the voltage upon this coil is more. So this mobile arm is connected to your mechanical machine. When the core comes, according the output voltage is going to differ. So this is the principle. So according to the movement in a resistance vary agala, the output voltage, you get the voltage directly, the output voltage is going to differ. So movement is converted to voltage variation, simple. So angiyavadhu we need to convert into so this, so when it moves upwards, more flux linkage on this coil. When it moved downwards, more flux linkage in the bottom coil. Accordingly, V out is going to differ. One bottom line principle is, according to the movement, output voltage differs. Here the movement is linear movement. So anga potentiometer pot lab, the movement is angular movement. Now I gave an example that car wipering kuda you can connect it, so you can measure it, right? So the next slide is, what is the cost of LVDT? So why I'm showing this is, you are final years, sometimes you might think of automating it, you might go for different sensors. See, it ranges from 1160 to 17,000. So it depends upon the accuracy, the range, at what indoor use or outdoor use, industrial use, adukku thagunda mari the sensors value or range might differ. Like how your cell phones, there are more variant, right? So that is how. So from minimum 1160 rupees, 1200 to 17 or 20,000 it goes, depending upon the application. And the strain gauge, it ranges from 250 rupees to even 1100 or 1200 rupees. So uh, that's the worth of a strain gauge and LVDT. LVDT costs more, right? So that's all for today. So I think it is 9:45. So you have an activity. So I'll post a Google form. There are simple 5 questions, like what was the title of the today, something like that, abbreviation of LVDT, and there are simple questions. So which you need to answer it, right? So I'll post the link in